Hi there, and welcome to today's class, guys. Today's class, we look at the concept of resistance and resistivity. So, let's look at the concept of resistance and resistivity. Before we move on, we have done several videos on the idea of resistance. So, I have done a tutorial video on resistance. So, I have made a video on my YouTube channel that talks about resistance, right? Resistance, Ohm's law, and whatever there. We have done that. So you can check out the video for that in my YouTube channel on my playlist. Go to physics playlist. You see the video on resistance. My focus for today's class is that I'm going to be focusing on the factor that affect the resistance of a material, right? So before then, what was the resistance? We know that a resistance is the opposition to the flow of current in a circuit. That's the resistance, right? So for today's class, I'll focus on the what's it called? I'll focus more on resistance, like Ohm's law, your two arrangements, series arrangement. I won't do that one. I've done that one before, right? So watch that video on that. So let's look at the concept of factor that affect the resistance of the material. Factor, factor that affect the resistance of a wire, of a half of a material, of a material. All right. What are these factors that affect material? Let's look at this concept one after the other. First is first. Now listen and listen, please. So the material we're talking about here could be silver, copper, or zinc. These are like three materials basically used to pass current, right? So what is first? Factor that affect the resistance of a material. Number one, please. We have the length of conductor. Number one. Number one, we have the length of conductor. All right. Number two, so length of conductor is the first factor that affects resistance of a material. Number two, there we have area of the conductor. Area of the conductor. All right. This one here is still the second kind of factor that affects the resistance of a wire, right? Number three there. Number three there, I have temperature. Temperature. All right. Number four, I have nature. Nature of material. Nature of material. These are simply the factors, the four factors that affect the resistance of a material are displayed on the board. So number one, there we have length of conductor, area of conductor, temperature, and nature of material. Now, how does this four affect resistance of a material? Now, listen, please note. Let's explain length of a conductor. All right, we know that if I have a conductor this way, if I have a conductor this way, of course, this is the conductor, right? So this conductor will have, of course, a length. Let me call here L. So let me call the length L, as in this case. So I have L. All right. This same conductor will have a diameter. So this diameter here, right? More of like the area, because if area and diameter are similar to each other, right? So with area, with diameter, I can get area. So this is your conductor here, right? So this conductor has a specific length and what? And a diameter. Now, how does length affect conductor? So note please, number one, note. I want to explain number one, please. Length of conductor, note please, note. The more the length, the more the resistance. Note please. For the first one, for this one, length of conductor, please note. The more the length, the more the resistance. The more the length, the more the resistance. So how does length affect resistance? It's simple. What's the idea? The more the length, the more the resistance. So if we need more resistance, we need to what there? Increase the length of that conductor. That's all. Right? So number one is explained. And I said this to this here is the length. So we said the more the length of a conductor, the more the resistance. All right. Number two, please. Area of the conductor, please. Let's explain this. Number two. Area of conductor. Put on, please. The more the area, the lesser the resistance. The more the area, the lesser the resistance. Please note that area of conductor affect resistance. How? Because the more area we have, the lesser resistance we have. That is for number two. I said the more of the more area, the lesser the resistance. All right, that's number two. Let's explain number three, please. Number three, temperature. For temperature, there, this temperature here is not really a double down concept to watch through. For like length, I can see physically, I can see the length. Area is clear, diameter is area. But temperature, you can't see the temperature with your bare eye, right? So you should just note that temperature is part of the factor that affect resistance, but it's not physical. You can't see it physical. The way I see length and area is physical, but I can't see temperature is physical. So what you need to note when it comes to temperature, please note this, please. Note please, temperature, please note. The more the temperature, the more the resistance. All right. The more the temperature on this wire, the more the resistance. All right. The more the temperature, the more the resistance. The more the length, the more the resistance. The more the area, the lesser resistance. The more temperature, more resistance, right? As we said recently. All right, so for temperature here, we said that the more the temperature, the more the resistance on that material, right? And the material we're considering here is a conductor, right? That's in quote like a wire, right? So first, I explained length, that the more the length of this conductor, the more the resistance, no problem. I explained area, that the more the area, the lesser the resistance. Temperature, the more the temperature, the more the resistance, right? So now when it comes to nature of material, when it comes to nature of material, it also affects resistance. How? Why? Listen, please. When it comes to nature of material, there are three mainly material that allow current to flow in them. We have number one is silver, copper, and aluminium. Now, we have silver. Silver is the best conductor so far. Why? Because it allows current to pass through them faster than even copper. Then followed by what? By zinc. Now, if you ask question that, sir, if you observe my fan, my light bulb, everything around me, I used the stuff, the material they used there is copper. If you check your environment, most of the wire you're using, your charger, most of those things are copper. Why not silver? Because we said silver is the best. Listen to this, please. In the market space, silver is expensive, right? So we people rather go for what a copper that is less cheaper. So most of our environment we use copper. Why? Because it's cheaper. Silver is more, it's expensive, right? They only use silver in some levels of projects. So that's like the concept behind that concept. We are asking that why is it that we're using copper, not silver, but silver is the best. We're using copper because using silver will not help the game. It's expensive, right? So using silver is a very, very expensive concept, right? So that's like idea. So your material you use determines. So if I use copper, if I use zinc, if I use silver, you can't expect the rate at which current will flow through it than using copper and using zinc, aluminium. You can compare the rate to which current will flow through. So that is why you said nature of material affect what there affect resistance. Now look at this. At this junction here, I said this please. For number one, we said length of conductor. We said the more the resistance, or perhaps the more the length, the more the resistance. So it means that resistance is then proportional to what? To the length. Because the more the length, resistance. So it means that R is what? Very proportional to what? Length. Number two, we said the more the area, the lesser the resistance. It means that R. All right, so we said number two, area of the conductor. So we said the more the area, the lesser the conductor. So I'm saying that that's like more of like inversely proportional to area. So the more the area, the lesser the what? The resistance. So I'll use that inverse to express lesser in area because they're not the same thing. For number three, there we said the more the temperature, the more the resistance. That is R is what? That's important to what? To T. Finally, nature of material has no mathematical expression for that. But here's the place. Now I'm saying this place that for number one, R is proportional to length. This is inverse proportional to the area, and R is proportional to what? To temperature. This is like the concept behind this place. Now, let me call this equation one, equation two, and equation three. Alright, so I'll combine one and together. So observe this, please. Observe this, guys. Observe this, please. Now we said I will only combine one and two. We said temperature is not a physical temperature can be felt. You can feel it, you can't see it, but you can feel it, right? So I'm saying that length and conductor are the only two visible thing you can see here of the diagram here, right? So in other words, I'll combine one and two alone. So combine equation one and two together. What do we have there? I will have that R is proportional to what? To length, and inversely proportional to what? Area. So this R and R is the same thing. So pick out one. So this symbol are the same thing. Just pick out one. So I have L as L here. This with this is this. So I'm having this that R is proportional to what? To length, and inversely proportional to what? To the area. So having this from here, I'll multiply length times 1, L times 1. That gives you R is what? That's proportional to what? Length over area. Alright. My next task here is that we said when it comes to moving this symbol, right? Proportionality symbol, we will introduce an equal to. So that becomes R is equal to, will be a constant term. So the constant here is no key, is what? Rho. This is a constant term called rho. It's called resistivity. Resistivity. That's rho dot what? L over area. Alright. Next task here, put it together. That gives you that R is equal to what there? Rho L over A. How we go please? So R equal to rho L over A as I have here. So I'll try to now what is this? What does this rho means? Note that the rho that we're having here. So notice please. Notice that R, we call R resistance in ohms. Right? Of course, use the unit ohms. Number two, we have length. In this thing, we have length too. We have length. Length, of course, in meters. We have area. That's This A is area of course in meters squared. We have rho. This is called resistivity, right? It's called resistivity. Resistivity, of course, it is measured in ohm meter. Ohm meter. Why? Why is it that resistivity is in ohm meter? Let's prove it. Let me show you how resistivity becomes ohm meter, right? How resistivity became ohm meter. All right. Next task says that we said resistivity is in ohm meter. Why is it so? We know fully well that we know fully well that I mean, all right. From here, we said resistivity is in ohm meter. Why? First things first, let's make ohm meter subject the formula here. So we have that R is equal to what there? Ohm L over A. Our cross multiply. That gives you um, RA equals rho L. Make divide both by L. L cancel L. I'll have the resistivity equal to what there? RAL. Now we know that R is measured in what? In ohms. That's the resistance in ohms. Area in meters squared. All over. Your length is in meters. Meter cancel meter. Meter square. I have 1 meter left. So I'm having that the S sign for ohms is what there is ohm meter. This is how we got to the essence of resistivity to be ohm meter as explained on the board.
If you're a teacher in Nigeria, the free class.
All right, we've been discussing about resistivity. I've mentioned resistivity so far, right? So let's define resistivity. Let's look at resistivity definition. What is resistivity? A resistivity is a property that describes the extent to which a material opposes the flow of current of electrical current through it. This is defined resistivity. And so resistivity, that the symbol is rho, and it's equal to what? R A over L. I've said the SI unit is what there is ohm. So we said resistivity said is a property that describes the extent to which a material opposes the flow of current through it, right? And we said it is represented by a Greek symbol called rho, and is equal to RA over L as displayed here, right? So I displayed here, right? And we said the S sign is what there is ohm meters, right? So let's look at another concept called conductivity. Conductivity. All right, that's K. Now, what's conductivity? By definition, this is a property. This is a property that describes the extent to which a material allows the flow of electric current through it. Conductivity is a property that describes the extent to which a material allows the flow of electric current through it. Mathematically, I have that conductivity K is what? The inverse of what? Resistivity. So don't forget please. Conductivity is the inverse of what? Resistivity. Right? That K is equal to what there? 1 over ohms. Sorry. 1 over rho. So note that resistivity, conductivity can also be defined as the inverse of what? Resistivity. And for my mathematical form here, I have this, right? So better still, if I want to express this can become K is equal to, all right, I'll have that K is equal to 1 over ohms. We know that ohms, yeah? We said ohms is what? The what's formula for ohms? Then ohm is what? Ra over L, as explained here. Moving on with this, I'll have that K is equal to what there? This is 1 divided by this line here is division sign. I have Ra over L. This gives you that K is equal to, I have 1 times, this one comes up N over Ra over Ra. This gives you K is equal to N over Ra. Alright, this becomes your mathematical expression, better still, for conductivity if you want to either use this or this. Alright, so this is how you find, this is how the concept of conductivity and resistivity work. And by the way, what then is the SI unit for conductivity? What then? That K equals length is in meters all over. This one is in rho. Area is in what? Meter square. Meter cancel meter. I have 1 meter here. So I'm having what then? K is what? 1 over ohm meter. More of like saying that the SI unit for conductivity is per ohm meter. Alright. Ohm meter. All to power what? Minus 1. So that's per ohm meter. So I have the SI unit for the SI unit for conductivity as 1 over ohm meter, or ohm meter to power minus 1. This is how the concept of conductivity works. I hope please. Let's take some example and see how this concept work much more better. One says, find the resistance of a wire of length 0.65 meter, radius 0.2 millimeter, and resistivity of 3 micro ohm meter. Let us first. How do you solve this question? It's simple. Solution, question 1. It says find resistance of a wire. So R resistance R is unknown. Length, they give us length to be what there? 0.65 meters, no problem. Radius of 0.2 millimeter. So the radius R is what? 0.2 millimeter. I'll convert this to meter. That gives you 0.0002 meters. Right? We have the resistivity. That's ohms. Resistivity is ohms. They give us as what? 3 micro ohm meter. All right. We know that this is 3. Micro is just a prefix. Micro is what? 10 to the power what? Minus 6. That's the value of micro. Then I'll drop my ohm meter, which is the main SI for what? Resistivity. So with this parameter given, we are asked to find what's it called? We are asked to find resistance. We know that resistance R is equal to what there? Rho L all over what there? All over A. Right? The resistance is rho L over A. With this, am I given to get R? I need 3 things: rho, L, and A. Am I given rho? Yes, it's given. Am I given length? It's given. Am I given area? No. Area is not given. But I'm given radius. So there's a way I can relate area with radius. Area and radius together. How? So I will recall that area is pi r squared. Right? I'll bring in the area. And why am I using per r square? Because per r square is the area of a circle. Why am I using circle? Why am I using area of a circle in this case? Because when I do the conductor for you, when I do a wire this way, this is diameter, right? This is where the radius will, this diameter, half of it is radius. So it's circular in nature. Circular in nature. That's why I'm using area of a circle. That's as my A in this case. Alright, so from here, A is what? Pi r square, area of a circle. Why? Because the conductor opening is circular in nature, right? This gives you area is equal to pi is what? 22 over 7 times what's radius? That's 0.0002 or what there? All square. This gives our area is equal to what there? From here, area is equal to 1.257, that's about what there? Minus 7 meter square. All right, I have this. That's my area. So let's get. So I know rho, I know length, and know area now. So I can get the value of what resistance.
So as we continue, sorry that I switched to this because my board is currently, sorry, my phone is storage is currently full, so I had to switch to this. So we just find area. If you check out what those is finished, you just go to area, and the area is 1257. All right, that is power minus 7 meter square. That's area. Our goal is to find resistivity, and we set resistivity R is equal to rho L all over area. This is now equal to rho is of course um, resistivity. We have to find resistance. Whereas resistivity is of course book is of course 3 times to the power minus 6 into the length there is 0.65. Next up all over. Here you have your area. Of course, in this case, area is 1.25 times to the power minus 7. Alright, so working on this, I'll have that resistance R will be equal in value to, if I punch all this in the calculator, I'll have 15.51. Of course, my resistance is in ohms, so I have ohms as my answer. This is how you solve this particular question, right? So we have to find resistance, and resistance is what is rho L over A, as I just showed you initially now. So moving on, guys, I want you guys to note that in this question we're only asked to find resistance, right? That's R, because the question says find the resistance of the wire of length 0.65 meter, radius 0.2 millimeter, and resistance 3 micro resistance 3 micro resistivity per se 3 micro ohm meter, right? So what of if we have not done, we have find resistance successfully? What of if, I'm saying this please, what of if we are asked to find K, and K is what? Conductivity. So what K? We know, recall that we said conductivity K is what? The inverse of what? Resistivity, right? So it means that K will be equal to 1 all over. If you check the value for resistivity, that's rho. What's the value in your book? Check the value in your book. Of course, that's what 3 times 10 to the power of what? Minus 6. Alright. Moving on. This gives you that K conductivity is equal to 1, 2, 3, 4, 5, 6. That's 1, 2, 3, 4, 5, 6 dots. 3 per ohm meter. Alright. Per ohm meter, as said. Ohm meters per minus 1. This is the value for conductivity. Just in case you have to find. This is how you find conductivity. Should we proceed to the next question? Question 2, guys. Let's move on to question 2. So alright, moving on, question 2, example 2, example 2, example 2, it says, what is the resistivity and conductivity of a cylindrical material wire whose 1.0 meter length has a resistance of 2.0 ohms with diameter of wire 0.5 millimeter? What do you do? First things first, what are you given? Solution to that question. It says what is resistivity and conductivity. So resistivity rho is unknown, conductivity K is also unknown. We are asked to find these two. Proceeding, that says of a cylindrical material wire whose 1.0 meter length, so length L is given as what? 1.0 meters, has a resistance R to be 2.0 ohms. With diameter is given as what there? 0.5 millimeter. First things first, our diameter, length, all those are in meters. So convert 0.5 millimeters to meters. That gives you 0.0005 meters. I will go now. Now my task is this, please. I'm asked to find resistivity, this one here, and conductivity, this one here. So if I know resistivity, this man, I can easily get what the conductivity, because it is the inverse. But guys, recall something, please. Recall that we said resistivity rho is equal to what there? Rho is equal to what there? R, perhaps 1, 2, rho is equal to RA all over L. RA all over L. Check your parameter. Am I given R? Before then, let me clear this stuff away. If you check what you are given, am I given R? Is R known? Of course, R is known, resistance is known. Am I given area? Of course, area is not given, but I am given what the diameter, right? So I can get area from what? Diameter. Am I given length? Of course, length is given as 1.0 meters. So let's first instead, let's get area. That's the only issue we're having here. So calculate for area, calculating for area in brackets A. We know that area in this is what? Pi d squared over 4. It is equal to pi into what's d? That's 0.0005 all squared all over 4. Right? Let me take the board up for a little bit. All over 4. Hold on, guys. Copy. So I have this one here, all over 4, all over 4, all over 4. This is equal to, I know that pi, if I work on this pi, know that pi is 22 over 7, right? So if I multiply everything together, I'll have that my area in this case will be equal in value to, that's 1.96 times the power minus 7 meters squared. That's the area. So area is now known completely. So I know R, I know area, I know length. I can get what the value of what? Resistivity. Alright. In other words, it means that resistivity rho is equal to rho is equal to R A over L. Put in values. What's R? R is of course 2 into what's A? Area is 1.96 times to the power minus 7, of course, all over the length there is of course 1, right? Moving on here, I'll have that my resistivity rho is equal to, punch calculator, I'll have 3.92 times to the power minus 7, of course, in ohm meters, I've got the value of what? Resistivity as 3.92 10 to the power minus 7 ohm meters. Next, we have to find conductivity K, right? So also um, conductivity, that's of course in brackets K. So we said K is equal to 1 over resistivity. That gives you 1 over 3.92 10 to the power minus 7. Alright, my final answer for conductivity K will be equal to 255,1020.41, of course, per ohm meter as my SI unit for conductivity. This is how you solve for this particular question. See you guys in the next class. This is the first time here. If it's the first time here, I would like you to share this video, leave a comment in the comment section, and also do to subscribe to my channel, please. Very important, please, guys. Subscribe to this channel for more educational updates. See you guys in the next class, and welcome to Excellent Link Academy.
Before we continue, let me quickly share something that can change your entire online journey. I just launched a complete YouTube mastery course, a step-by-step training designed to help beginners start and grow a successful YouTube channel using only their smartphone. In this course, I break everything down in simple, practical lessons. No expensive camera, no studio, no complicated equipment, just your phone and the right knowledge. You will learn how to create quality videos, design engaging thumbnails, write perfect titles, choose the right niche, understand the YouTube algorithm, and grow your channel from zero, even if you've never created a video before. If you want to become an online teacher like me, this course will guide you on how to teach online record lessons, explain concepts clearly, and attract the right audience. And if you want to create content in any other field, lifestyle, motivation, entertainment, business, this course will still show you the exact steps to succeed. All the lessons are pre-recorded, well-organized, and easy to follow. You can watch them at your own pace, anytime, anywhere. So, if you've been dreaming of starting a YouTube channel but didn't know how to begin, this is your opportunity. This course will take you from beginner to confident creator. The link to get the YouTube Mastery course is right there in the video description. Click it and start your YouTube journey today. With studying, losing motivation, or you feel like you're working hard, but your results aren't showing, this is for you. I recently released a powerful book titled The Shortcut to Academic Success. It is a simple, practical guide that shows you exactly how to study smarter, stay focused, remember more, and achieve outstanding results without stress. This book is not theory. It's a step-by-step roadmap I created after years of teaching students and understanding what truly works. Inside, you'll discover proven study techniques, exam strategies, productivity hacks, memory boosters, and secrets top students use every day. Whether you are in secondary school, university, or preparing for any exam, this book will transform the way you learn and help you reach your academic goals faster. And the best part? It costs only 2,000 Nigerian nairas, less than the price of a snack, but the value inside can change your entire academic journey. If you truly want to upgrade your grades and finally take control of your learning, don't wait. Get your copy of The Shortcut to Academic Success today. Your future self will thank you.